These are the solutions to 2025's A21, and this is Mathematics A-Level Exam, the Pure Module. So the first thing you do is read the paper. It says 3 significant figures unless stated otherwise, and the total mark for the paper is 150. Now I've already done this out, did this out earlier, and it didn't record, so I've these answers all written in, and we'll be whizzing through this and getting through this as quickly as possible. It says list the terms of the following sequence for n is equal to 1, 2, 3, or 4. So how I've got these values, first of all, if you put 1 into the top line, 2 times 1 squared, then 3 plus 1, that will give you 2 over 4. If I put 2 into the top line, you get 2 times 2 squared, which is 8, and then 3 plus 2, which is 5 in the bottom line. 3 into the top line, 2 times 3 squared, which is 18. 3 plus 3, which is 6, and 4 into the top line, 2 times 4 squared, which is 32, and then the bottom line, 3 plus 4, which is 7. That is no use to me. When I put them in the decimals, I got 0.5, 1.63, and 4.57, which clearly is getting bigger, which means it diverges. The next one, again, you're looking for, this is n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4. And you can see you got minus a third, minus 3 over 6, minus 5 over 7, minus 7 over 12. And that is minus 33, minus 0.5, minus 5.5, and 0.58, sorry. And that converges. Now, it doesn't ask us to do this, but what you could do is look at what happens to the thing as n tends to infinity. So as n tends to infinity, 1 minus 2n over 3n would go to basically 1 minus 2 times infinity over 3 times infinity, which is pretty much the same as minus 2 over infinity over 3 infinity, and infinities cancel out, just giving you minus 2/3. And if memory serves me correctly, I put in 1,000 into my 1 minus 2n over 3n, just to show you, and you can see, put in 1,000 into it, 1 minus 2 times 1,000 over 3 times 1,000, and it works out to be minus 0.666333, which is very close to 2/3, as we said. So you can see it is converging. So that's a nice way of doing it. Just basically put in a very large number to see what happens. Okay, the next one, it says the fourth and ninth terms in an AP, an arithmetic progression, are 89 and 69 respectively. Find the first term and the common difference. Now this is using the fact that my general term for an AP, an arithmetic progression, is, my nth term is a plus n minus 1d. So it tells me the fourth term is 89, so that's this, and it also so that's 89 is equal to a plus 3d. The ninth term is equal to 69, so that's this one here. The ninth term is 69. 69 equals a plus 8d. Now, this is just a simultaneous, these are a pair of simultaneous equations, which you can go on and solve to give you d is equal to minus 4 and a is equal to 101, is that right? Yep, 101. Okay, right, so your general term, remember, is u is equal to a plus n minus 1d. We'll need this for the next part of the question, that's why I'm doing this. This is all you needed to get the first part, but we will need this for the next part of the question. So my general term was un is equal to a plus n minus 1d. We know our a is 104. We know our d, 101, sorry. Your d is minus 4. Multiply that out and tidy up. You will get this thing here. We'll be using this in the next part of the question. So un is 105 minus 4n. So it says, in this AP, the last term is the only negative term. So it's the first one that becomes negative. Find the number of terms. So your last term, we're just going to say 104 minus 4n. That was my last term. And I'm going to put that less than 0. It's just a wee linear inequality, which means 104 is less than 4n. Divide across by the 105 is less than 4n. 105 divided by 4 is less than n, or that means n is greater than 26 1/4, so n is equal to 27. And we could just test that out. That was my un. Un was equal to 105 minus 4n. Let's put in 26 105 minus 4 times 26, and if you did that out and see what you get, 105 minus 4 times 26, that works out to be 1, so it's not negative. 27 term, 105 minus 4 times 27, 105 minus 4 times 27, and that's minus 3. So you can see, I was right there, the first term to be negative is the 27th term. Alright, not a nice question here, this one. This one you've got your f of x is drawn, and you've got the point 0,4 is p, and q is 2, 2. So that's what you've got. And the first part of the question says, on the axis below, show the graph of y is equal to y equals 1 plus f of x over 2. Now notice, first of all, I can write this as 1 plus a half x, f of a half x. So what does that mean, the f of a half x? Well, you know, f of ax, what it does, it stretches something horizontally, scale factor 1 over a. So that means f of a half x stretches something horizontally, scale factor 1 over a half, which means scale factor 2. So it's stretched horizontally, scale factor 2. What that means, everything's pulled out this way, times 2. Everything's pulled out this way, times 2. Now this bit we don't need, because there isn't anything out in our graph that direction. And then the last bit, the plus 1, means you move everything up by 1 unit. So let's have a look first of all here. This point is going to stay fixed. This point is going to move out by 2. And then everything's going to shift up by 1. So your point here is that's going to go to 4, 2. Then it's going to shift up to 4, 3. And that point's just going to shift up to 0, 5. So that's really what's happening first of all. So that's going to, yep, you can see that's what all we've got. There's our 2 key points. And then the general shape of the graph is pretty much the same. Next one is y is equal to 4 minus f of x. Now minus f of x is a reflection vertically. And just think about it that way. If the a value or the minus or whatever is outside the bracket, it's in the vertical plane. If it's inside the bracket, it's in a horizontal plane. So what we've got to do here, you've got to do this bit first. So that's the reflection vertically. And then this bit, which is we'll move it up by 4. Now notice how I've done this. I've done this in 2 steps. First of all, I reflected my original graph vertically. So that means, just here, just to show you, this 4 will go down to minus 4. And this point here will go down to here, so it'll have that general shape. Okay, so there's the dashed line is what I've just done, and then I've just shifted the whole thing up by 4. So the p first of all went to 0 minus 4. The q first of all went to 2 minus 2, and then if you shift them up by 4, it goes up to the origin, and then q goes up to the point 2, 2. Okay, next one, much nicer question here. It says Ella wants to make party hats for her son's birthday party. She creates a template by cutting a major sector AOB from a circular card. The card has a center O and a radius 10 centimeters. So, and what you have to do is she will then fold the card into cones before decorating them. The template must have a major arc length of 14 pi. So 14 pi, you can see I've labelled on, is a length all the way around from on the circumference from A to B, that big long arc. Now the arc length is L is equal to R theta. So 14 pi equals R theta, and you know your R is 10, so 14 pi equals 10 theta, which means theta is equal to 14 pi divided by 10, so that's just going to be 1.4 pi. So that's what we get. Part 2, I've done it up here. It says find the area of the card wasted. The area wasted will be this shaded bit here, this bit in yellow. So the first thing I'm going to do is find alpha. A whole revolution like this would be 2 pi radians. So we're going 2 pi but then we're taking away that theta, which we knew was 1.4 pi. So 2 pi minus 1.4 pi, leave it as 0.6 pi, that's lovely. And then the area of a sector, pizza slice, is a half r squared the angle times the angle. So a half times 10 squared times 0.6 pi, which is 30 pi. That, by the way, is what's called exact, but give it a 3 sig figs as well. So 94.2 centimeters squared to 3 sig figs. Okay, that's that one done. We had that one done up there. Okay, right. Now this one here, this is one where you need to be going into an exam knowing what these graphs look like. But if you're like me and you're incredibly bad at learning revising graphs, revising in general, you maybe want a wee help. So we were asked to draw the graph of cut. So I have a vague idea of how it works, but I quite often forget which way around the shape goes. So there's my tan graph. A couple of key things. Tan has got what's called asymptotes at 90 degrees and then every 180 degrees before and after. So at 90 degrees and 270 degrees. And also the general shape of the tan graph, it's just that wee shape I've just drawn here, repeated. So cut is the same, but reflected, if you know what I mean. So it's reflected or rotated by 180 degrees, whatever way you want to say it. So there we have, that's what the cut, the general shape of the cut is. And you can see there's my cut. But notice tan is equal to 0 at 0, at 180 and at 360. So 1 over 0 would be at 0, at 180 and 360. So there's actually asymptotes at 0, at 180. Sorry, I should have marked it on 90 there. At 180 and then at 360 there's asymptotes. And then it has that general shape as I said as well. There was a tan, there was a cut. So there we're good to go. Okay, next one. Lovely wee one is an identity. For an identity question, it mentions here, it says prove the identity 2 cot 2 theta is identically equal to cot theta minus tan. I would work with my left hand side. Because I have a tan on the right hand side, I'll change my cot to be 1 over tan. So instead of 2, left hand side is 2 cot 2 theta, I'm going to write that as 2 over tan 2 theta. Now tan 2a, and how you can get this, from your formula booklet, you're told that tan of a plus b is tan a tan b over 1 minus tan a tan b. So if you just let a equal b, or a equal a and b equal a, so that means instead of tan 2a it becomes tan of a plus b becomes tan 2a, and you will get this formula. Okay, you really should know that anyway without, but that's how you can get it from your formula. So if that's what tan 2a is, 1 over tan 2 theta would be this thing here. So that's what 1 over tan 2 theta would be. And then the 2's cancel out, leaving you 1 minus tan squared over tan. And then that's the same as 1 over tan, and then minus tan squared over tan. 1 over tan, this thing here, is the same as just cot. And tan squared over tan is the same as just tan. And that's what we were looking for on our right hand side. Lovely. Next of all was it says hence or otherwise find solutions of. And it said cot theta minus tan theta equals minus 2. We have now been told that cot theta minus tan theta, we now know from the previous part, cot theta minus tan is the same as 2 cot 2 theta is equal to minus 2. All I've done here is divide through both sides by 2 to get cot 2 theta equals minus 1. And then I reciprocal both sides. That's a very funny word there, but that just means turn it upside down. So cot, remember, is 1 over tan. So 1 over cot just becomes tan. 1 over minus 1 still becomes minus 1. Now notice my angle isn't just theta, it's tan of 2 theta. So we'll write down our range. The original range was over here, was 0 to is less than or equal to theta is less than 360. Double the theta, you get 2 theta. Double 0, you get 0. Double 360, you get 270. Okay, 4 angles to get here. I'll show you how I get them. Okay, first of all, you do your basic angle. Tan to the minus 1 of 1 gives you 45. Don't do tangent minus 1 of minus 1. Do tangent minus 1 of 1. Gives you 45. And then the minus tells you which quadrant to put it in. So in my cast diagram, it goes in the C quadrant and the S quadrant. Now my first angle is 45 shy of being 180, so which is 135. The next one is 45 shy of being 360, which is 315. The next one, all the way round, and then round again, another 135. Or a smart way of doing it is just add 360 to this one to give you 495. Exactly the same for the last one. I have to go all the way around to get to here. Then keep going, another 360 to get to here. So again, it's this one here plus 360 to give me 675. Divide them all by 2 and then give your final answer to 3 sig figs, and hopefully that is correct. Hopefully that's what we're looking for. Okay, what do I want to? Question 6. Right, it says differentiate a function f of x with respect to x, where f of x is defined by. Okay, this is a product. What you could do here, what you could do here, what have I done? Bring that back. Right, what you could do is use the product rule. I have decided not to do that. There's a product rule. Y is equal to UV. You'd write down V du by dx plus U dV by dx. But what you can also do is just differentiate the first, write down the second, differentiate the second, write down the first, which is what I've done. So hopefully you're happy enough with that. Now, before I get started, the formula book tells me if I differentiate cosec, I get minus cosec cot. Differentiate cosec, I got minus cosec cot. So here we are. Right, so here, let me just piece through what I've done here. This is my first, and then in blue, this is my second. So in red then, I have differentiated the first, written down my second. Then what I've done is differentiate the second, and then written down the first. Now let's just zoom in on this bit. This is me differentiating the second. So differentiating cosec 3x. Told you in the formula booklet, if you differentiate cosec x, you get minus cosec x cot x, which we've got then. The angle always stays the same, so minus cosec 3x cot 3x. But then you've also, and this is a bit people forget, you've got to differentiate the angle too. Okay, an absolute mess. Tidy that up. It's going to be 2 e to the 2x plus 1 cosec 3x, and then minus, have I done that right? Yes, minus 3 e to the 2x plus 1 cosec 3x cot 3x. You could go on and take out an e to the 2x plus 1 cosec 3x, and that's going to be times 2, and then minus 3 cot 3x. I don't think that's any big help, to be honest. I don't think I would bother doing that. But if you had done that, I'm sure you're not going to lose any marks for it. Okay, right. Now the next one. Right, what we've got here, it says, let me tidy this up a wee bit, apologies. It says a curve is given by the equation 2x plus 5x squared over y cubed equals 3. Find the equation of the tangent at the point minus 1, 1. Leave your answer in the form ax plus bx plus c equals 0, where a and b and c are integers. First thing I've done here, notice, is I have written it in index form. So 2y plus 5x squared, y to the minus 3 equals 3. Now what we're going to do here is we're going to write down differentiate, and I would just say WRT x. That means differentiate with respect to x. So what I'm doing here is everything's getting differentiated. 2x gets differentiated to give you 2. And then this over here, this middle term differentiates to give you this whole big bracket. 3 differentiates to give you 0. Now let's just look at differentiating, where is it? How we would differentiate like a y term. So here, if I'm trying to differentiate a y term with respect to x, I'm using what's called the chain rule. So I'm going to have to differentiate, I can't differentiate y to the minus 3 with respect to x. So what I've got to do is differentiate with respect to y and then multiply it by dy by dx. Now this is a very simplistic way of thinking about it, but it's as if they just cancel out and that gives you the result. So if you were to do this, if you were to differentiate this with respect to y, you would get minus 3y to the minus 4 and then just dy by dx. The really basic way of doing it, if you're differentiating something in terms of y with respect to x, differentiate with respect to y and then just slap dy by dx on the end of it. Okay, so a really easy example, like if I was differentiating 4y squared with respect to x, differentiate with respect to y would give you 8y and fire dy by dx in the end. That's as quick and easy as it is to do it. Okay, right. We're using the same sort of method I used up here. Differentiate the first, write down the second. So here, I've got these bits here. I'm going to differentiate this, and that's going to give me 10x. Then write down the second. And that's all I've got. Okay? Oops, let's do that again, the next bit. And then for here, I'm just going to write down the first and then differentiate the second. So differentiate this, it's going to be minus 3y, reduce the power by 1 to minus 4, and then slap a dy by dx on the end, and that's it. And remember, if we differentiate the 3 on the right hand side there, you got 0. That's an absolute mess. Tidy it up, multiply it out there, you can see you'll get 2 plus 10x y to minus 3 minus 15x squared y to minus 4 dy by dx equals 0. And then I've just fired the minus 15x squared y to minus 4 dy by dx across the other side to make it positive. And then just divided back across by the 15x squared y to minus 4. So that's what my dy by dx is. A lot of people aren't going to like it written this way with a y to minus 3 and so on. It doesn't matter. Leave it as it is. You're going to be putting values in the calculator. The question asks you to find the equation of the tangent of the curve when y at the point minus 1, 1. So just say at minus 1, 1, your dy by dx is equal to, and you can just fire this into your calculator, 2 plus 10 upon minus 1, and then that's 1 plus 1 to the power of minus 3 technically, which is just going to be 1 anyway, and then 15 times 1 squared, 1 squared, and then times 1 to the power of minus 4, and do that in your calculator, you'll just get minus 8 over 15. Now I'm going to put that into the equation. My tangent is y equals mx plus c. You may prefer this, whatever you prefer. I definitely prefer the top one. I'm going to use y equals mx plus c. So tangent is y is equal to minus 8 over 15x plus c. And then sub in the point. So I would just say, put a wee word in, at minus 1, 1. My y value is 1, my x is minus 1. Tidy that up. 1 equals 8 over 15 plus c. Bring the 8 over 15 across. 1 minus 8 over 15 equals c. 7 over 15 equals c. Y then equals 8 minus 8 over 15x plus 7 over 15. Multiplied through by 15, you get 15y equals minus 8x plus 7. Bring it all to one side. 8x plus 15y minus 7 equals 0. Really nice wee question. Very nice indeed. Okay, where are we? Question 7. Okay, right. This question here is a very common one. So this is what the question gives you. It says show that sine, and this is part 1, which is key in here, show that the integral of sine x squared is equal to this. Because this is labelled part 1, you're probably going to use this later on in the question. So they've been very nice to us giving you this part of the question. So to do this, to integrate sine even parts of sine or cos, you're using the double angle formula for cos. Now the double angle formula for cos, which involves sine, is this boy over here. So cos of 2x equals 1 minus sine squared. Rearrange that, switch the minus 2 sine x squared and the cos 2x around. You'll have 2 sine squared x equals 1 minus cos 2x, and then divide through by the, or multiply through by the, divide through by the 2, so the half goes across, and then you've got a sine squared is equal to a half upon 1 minus cos 2x, or sine squared equals a half minus a half cos 2x. So now your integral of sine squared becomes the integral of a half minus a half cos 2x dx. And you must know this going into your exam. If you integrate cos mx dx, you get 1 over m sine mx. So the angle bit, this bit here, stays the same. Okay, if you go into an exam not knowing that, not well enough prepared. So if we integrate our cos 2x, what I've done here, I've integrated my cos 2x, that gives me the half sine x. Integrate a half, that just gives me a half x. And also you've got a minus a half multiplying your half sine x. Tidy it up, you will get a half x minus a quarter sine 2x. And if I look back, that's not what I wanted. But remember, sine 2x is the same as sine 2x is the same as 2 sine x cos x. So this bit here, we can rewrite as 2 sine x cos x. So it becomes a half x minus a quarter upon 2 sine x cos x plus c, which is then a half x minus a half sine x cos x plus c, as we were asked to get. Okay, the next bit of this question, wherever it is, there we are, said a vase or a vase is modelled by rotating the curve y is equal to 2 minus sine x between x equals 0 and x equals 2 pi. This is using volume of revolutions, which says volume is equal to pi, the integral between x equals a and x equals b of y squared with respect to x. That's how you find a volume of revolution when you rotate around the x-axis. So here, I guess we've got down. So it's the integral in this case. V is equal to volume is equal to pi times 0 to 2 pi, because 0 was here, 2 pi was here, of y squared. Now my y was equal to 2 minus sine x. Square that out. 2 minus sine x squared gives you this whole thing here. And why we needed to do our part 1 of our question, which you can see, part of this involves us integrating sine squared. And we know what that is from earlier on. When you integrate sine squared, you get this. When you integrate 4, you get 4x. When you integrate the 4 sine x, you get 4 cos x. And then it's been integrated, so your limits are now on the right-hand side. Fire those in. I'll just leave it on the screen for a wee second and you can see what you would get. The first bracket is 8 pi plus 4 plus pi plus 0. Second bracket would be 0 plus 4 plus 0 plus 0. Remember, your calculator is in radians mode. That is absolutely key. If you're doing any integration, differentiation involving sine or cos, any calculus at all, including your trapezium rule, because it's an approximation for an integration, then your calculator must be in radians mode if there's any trig at all involved. Okay, and then we sort that out, wee bit of working out, you'll get 9 pi squared, and it's volume, so it's units cubed. Okay, let me tidy this mess up here, apologies. Right, it says here the function f of x is equal to 3 upon 1 plus ln x, and that's squared. It has a stationary point P, which lies on the x-axis. Using differentiation, find the exact value of the coordinate of P. So there's your f of x. What we're going to do is differentiate. So this thing here is a function of a function. You've got 1 plus ln in a bracket, and then it's being squared. Differentiate with respect to the power. The 2 comes down and multiplies to give you 6. Bracket stays the same. Differentiate inside the bracket, you get 1 over x. So your f dash is equal to this thing here. Now to find if something's a turning point, you put dy by dx equals 0, or in this case f dash equals 0. And because that's a quotient, that's just a fraction, you just need to put the top line equal to 0. So 6 plus 6 ln x equals 0, or 6 ln x equals minus 6, or ln x equals minus 1. Inverse of ln is just e to the power of something. So that means x is just equal to e to the minus 1. That's your exact value. We did have to show, it did say to prove its minimum. So you're going to have to go on and do f double dash of x. So that's your f dash of x is equal to this. Top line is your u. So u is equal to 6 ln x. Your bottom line is your v. Differentiate your u to get du is equal to 6 over x. Differentiate your v to get dv equals 1. And then your f double dash of x is equal to v du minus u dv all over v squared. And v du is this thing minus, that's my u dv all over my v squared. And that tidies up to be 6 minus 6 ln x over x squared, or just minus 6 ln x over x squared. So what that should say there is when x is equal to e to the minus 1, put that in, minus 6 ln e to the minus 1 over e to the minus 1 squared. Ln of e to the minus 1 is just minus 1. So minus 6 times minus 1 on the top line is positive. E to the minus 1 squared is positive. So it's greater than 0. That shows you it's a minimum. So your point e to the minus 1, 0 is a minimum turning point. Phew. Okay, right. The next bit says state the equation of the vertical asymptote of the function. Now, that was my function up here. It has a, if you do ln of 0 on your calculator, it comes out as math error, doesn't work. Okay, so the vertical asymptote happens when x is equal to 0. Basically, that is it. So the vertical asymptote is when x is equal to 0. And if you even look here, that was the original, ln graph. You can see it has an asymptote when x equals 0 because it doesn't exist. So that was my function. My function was 3 upon 1 plus ln x squared. X equals 0 is going to give you a math error. That means x equals 0 is a vertical asymptote. Right, my goodness, right. State the domain and range of the functions. Right, I do not profess to be great at functions, and I'm not a big fan of functions. But the domain is the x values it covers. The range is the y values it covers. So I've got this written down, the answer. Let's go back and look and see what it is, what I've said here. So the domain is the x values which are covered. So my domain is going to be out here. And remember, you're not allowed to be x. You're not allowed to be x equals 0. And my range is the y values which are covered. So my range is anything at 0 or above. So that's key. So horizontally, our domain was x belonging to the set of rails. And then double dot means such that x is greater than 0. We weren't allowed to be on the y-axis, remember. But my range is f, the vertical end, belongs to the rails such that f is greater than or equal to 0. We were allowed to be on the x-axis. Remember, there was a value on the x-axis. I think it was minus or e to the minus 1, 0. Right, this is a tough question. I cannot, for 1 mark, I cannot see many people getting this at all. Right. Okay, it says here, f of x can be considered as a composite function such that f of x is equal to hg of x, where g of x is equal to ln x minus 1. And h of x has a domain, that's it. And yeah, you've got your h of x. So let me go through that again. F of x can be then written as f of x equals hg of x. That means you do your g first and then you do your h. And they tell you your g of x is equal to ln of x minus 1. Now, they want me to find the function h of x. So write down, I'll leave that on screen that we can see that, but f of x, is 3 upon 1 plus ln x plus 2. So that's what you've got for your first line. Your next bit then is we want to change that to get it into the form that they want. So I want to have my g of x written in its form. So they'd written g of x as ln x minus 1. So all I've done here is I've changed this thing here, 1 plus ln x, I've written as ln x minus 1 in a bracket, that's my g of x, and then plus 2. So you can see the bits highlighted in blue are mathematically equivalent to each other. Okay, but now then, why I've done that is, that bit then, if I can get rid of those blues again, this bit then in green, that's what my g of x is. So my f of x is 3 upon g of x plus x, and then that's squared. So that's the same then. My h of x then, remember I was doing, it was f of x was equal to hg of x. So what is this h doing to the x? It's to the g of x. It's taking it, and then you're adding 2 to it, and then you're squaring it, and then you're multiplying it by 3. So that's what your h of x is. For 1 mark, trust me, very few people are going to get that 1 mark. That's going to be very, very tough. Now the last bit says find the inverse function g of x. So to do this, you've got your g of x, you write down your g of x, which was ln x minus 1. Then you let y equal ln x minus 1. Then what you're going to do here is make y the subject. So bring the minus 1 across, you'll have y plus 1 equals ln x, which means ln x is equal to y plus 1. All it did is switch those around. Then inverse of ln is the e to the power of something. So xn is equal to e to the 1 y plus 1. That means your g to the minus 1. The inverse is e to the x plus 1. Most of your marks for that. Now, for the next bit, what I've done here, I would have to write down what I'm going to do. We sketch again of ln of x. So ln of x looks like this. That's my y equals ln of x. So ln of x minus 1 is the exact same graph, but it's just gone down by 1. So that's ln of x minus 1. So notice here what the range, so that's what my g of x is. It was ln of x minus 1. The range of it, it covers down to minus infinity up to positive infinity. So the range of it is g belongs to the set of reals. Why on earth am I talking about the range of g of x? I'm talking about it because we are asked to find the domain of the inverse. Now the range of a function is the same as the domain of its inverse. So the range of my original function was everything belonging to the set of reals. So the domain of my inverse is everything belonging to the set of reals. Okay, question 9. Lovely little trapezium rule question. Now, if I get a trapezium rule question, what I do is I do the same wee terrible sketch every time. So it says, use the trapezium rule with 4 strips to find approximate value 4. The integral between 0 and 1 of 2 over 5 plus root x and dx. So what I'm going to do is I'm going to do the same wee diagram. And you can see there all like wee trapeziums. Not very obvious there, but they're going to be used in approximation. Now, horizontally it goes from 0, there's 4 strips, it goes from 0 to 1. So if you split that into 4, each strip has a width of 0.25. And notice I've labelled these y0, y1, y2, y3, and y4. Now to get these values here, this one here, you can see I've got my x values, so 0, which are the endpoint, 0, 0.25, 0.5, 0.75, and 1. This thing here, just about keep that on the screen, this is my y0, and this is my y4. They are my end values. Everything else are my others. You might have said the rest. That's y1, y2, and y3. How I got those values, for example, to get y2, which was when x was 0.5, I put 0.5 into this thing, which gave me 0.3044026. Okay? And then we can use the trapezium rule, which is basically area is equal to h over 2 upon the ends plus 2 times the others. And then you can see my ends add to be 11 over 15. a lovely value. If the other ones had worked out to be nice values, I got great. Nice fractional values. It didn't give me nice values in the calculator. So my others added up to 1.05502229. Fire those into the calculator, and I got my h was 0.25. 0.25 over 2 upon 11 over 15 plus 2 upon 1.05502229. Fire that in the calculator, 0.355. And we're going to see in the next part of the question that's a pretty good approximation to what it actually is. Okay, next part of the question says, using the substitution for u is equal to 5 plus root x, find the value of the integral from 0 to 1 of 2 over 5 plus root of x. So first thing you do is you try and change your du or your dx into du. So you write down your u, which was 5 plus, and I written it in an index form, so 5 plus x to the power of a half. Then du by dx is equal to a half x to the minus a half. And then multiply across by the dx you'll have, and as well bring that half across, divide across by that half, you'll get 2. So you'll have the integral of 2 du is equal to the integral of x to the minus a half dx. Now I could write the x to the minus a half as 1 over x to the power of a half. And then if I bring it across, I get this thing here. So 2x to the power of a half du is equal to dx. Now that's a wee bit awkward. So we'll go back up here. Remember, u was equal to 5 plus x to the half. So x to the half would be u minus 5. So instead of this line here, we would rewrite it in terms of the left-hand side in terms of u, to integral 2 upon u minus 5 du. There are so many different ways of doing that. That's just one of multiple ways you could have done that, but that's fine. Okay, right, let's have a look at what we've done so far. Our bottom line, we know that's just u, and we've changed our integral and our dx. We need to sort our limits out, so we need to do them. So the limits were x equals 0 and x equals 1. So remember, our conversion was u is equal to 5 plus root x. So when x equals 0, 5 plus root of 0 is just 5. So u goes to 5. When x equals 1, 5 plus root of 1 is just 6. So u goes to 6. So this is what our integration becomes. Remember, we changed our integration sign and our dx to be integration sign du and 2 upon u plus 5. We changed whatever that was in the bottom, 5 plus root x to be a 0. We changed our limits to be 5 and 6, and we already had a wee 2 outside the front as well. Okay, that's an absolute mess. Let me get rid of those. Okay, mess, so tidy it up. 4 upon u minus 5, then that becomes 4u minus 20 all over the u. Divide through by the u, you'll have the integral of 4 minus 20 over u. Integrate then, you'll have 4u minus 20u, and that's between 6 and 5. Fire the 6 in, you'll have 24 minus 20u, 20 ln 6. Fire the 5 in, you'll have 20 minus 20 ln 5. 24 minus 20 is 4. 20 ln 6 minus 20 ln 5 is plus 20 ln 5. And then that becomes 4 plus ln of 5 over 6, which is 0.354. I think our answer to the last part was 0.355. So you can see our trapezium rule was pretty darn good. Okay, now the last bit says, as good as it was, they didn't think it was good enough. It says, explain how to use the trapezium, how the use of the trapezium rule in part 1 could be modified to obtain a better approximation. Use more strips, I would say. Use more strips, or use, yeah, I think more strips is the only way to do it, so that would be a better approximation to the curve. Okay, right. Bear with me, I've got a wee bit of highlighting to edit out here. Okay, lovely question. It says the expression Root 2 cos x plus sin x can be written in the form r cos x minus alpha. So what I've done here is just written out 2 root 2 cos x plus sin x equals the expanded version of r cos x minus alpha is r cos x cos alpha plus r sin x sin alpha. You can use your formula booklet to help you with that. Now all we're going to do is look at the cos x. So in blue, what's multiplying cos x on the left hand side is 2 root 2. On the right hand side, what's multiplying cos x is r cos alpha. So there we are, r cos alpha equals 2 root 2. It's in yellow, sorry. And then the sines, 1 really is multiplying sin x here. R sin alpha is multiplying it here. So 1 is equal to r sin alpha. Sine divided by cos gives you tan. So the blue one divided by the yellow one will give you tan alpha equals 1 over 2 root 2. And then tan to the minus 1, it's in degrees. So it's 19.4712 or 19.5. To get your r, you just square those things. So this squared plus this squared and then square root. So 1 squared plus 2 root 2 squared and square root. And that gives you r equals 3. Okay. Now, we could have said then, sorry, let me move this up a wee bit that we can actually see it. We could have said then that 2 root 2 cos x plus sin alpha is the same as 3 cos x upon x minus 19.5. It says, hence determine the minimum value of this thing below. Now it's not quite the same as what they had. It's not quite 2 root 2 cos x plus sin alpha, because it was 4 root 2 cos x plus 2 sin alpha. So really it's 3 plus 2 upon, and then that thing then. So, and remember this thing, we could say that's the same as 3 cos x minus 19. And then 2 times 3 is 6 cos x minus 19. Question just says find the minimum value of this thing. The minimum value of cos is minus 1. So the minimum value of our thing will be 3 plus 6 times minus 1, which is 3 minus 6, which is minus 3. It doesn't ask you to do this, that's the answer. You've got your marks. It doesn't ask you to do it, but just in case this came up. So that happens when cos of x minus 19 is minus 1. And that happens when the angle bit equals 180. So that equals 180. And then bring the 19.5 across, you'll have x is equal to 199.5. That's all it would be for that question. Okay, we're getting there. Okay, right, nasty enough wee question here, this one. Right, you've got toy cars moving around a circular track such that its coordinates relative to the fixed origin O are given parametrically by x is equal to 3 cos t plus 4 sin t plus 2, y is equal to 4 cos t minus 3 sin t minus 1. By using parametric differentiation, show that dy by dx equals 2 minus x over y plus 1. Right, differentiate first of all, do your dy by dt, and that gives you minus 3 sin t plus 4 cos t. Differentiate your y, that gives you minus 4 sin t minus 3 cos t. Now what parametric differentiation is about? It says dy by dx equals dy by dt times dt by dx. So that is your y1, dy by dt, divided by the x1, because remember, dt by dt is just 1 over your dx by dt. So that's where that comes from. So you've got your dy by dx, right? And this bit, folks, I'm going to guess probably about 75% of people got that bit. If they started the question, they got it. But then they didn't know where to go. So keep one eye on the prize. This is where you're trying to get to. You're trying to get to this thing here. Well, was that 2 minus x over y plus 1. So keep one eye on where you're trying to get to. And notice that was your original x was 3 cos t plus 4 sin t plus 2. So you could just bracket that thing off and say that's the same as 2 minus, and you can see where you'll get there. Right, that's not nice. But you've got, I'd imagine you've got 3 marks anyway. You've got a mark here where I've got that tick, a mark for the next one, and probably a mark for this. If you don't get those last couple of marks there, you've missed this mark and you've missed this mark. You've got 3 out of 5 marks, which a lot of people aren't going to get because they're going to give up or they're going to score out their working out. Now, the next part of the question says, initially the car was at a point with a coordinate 5, 3. By solving the differential equation, find the equation of the track. So the differential equation we were given was dy by dx is equal to 2 minus x over y plus 1. A bit of like cross multiplying. The integral then of y plus 1 integrated with respect to y equals the integral of 2 minus x integrated with respect to x. Integrate everything. Left hand side integrated gives you y squared over 2 plus y. Right hand side integrated gives you 2x minus x squared over 2 and then plus c, your constant of integration. I'd multiply through by 2 to get rid of my 2's in the bottom line. So then y squared plus 2y equals 4x minus x squared plus 5. You're told about this point, 5, 3. Fire in the 3 for the y's and the 5 for the x's. So you'll have 9 plus 6 equals 20 minus 25, or 15 equals minus 5 plus c. That means 20 equals c, and then your final answer, y squared plus 2y equals 4x minus x squared plus 20. Okay, almost there. Okay, write the following expression in partial fractions. First thing, multiply at the bottom line and see what it is. The reason you're doing this is you've got to divide first because the order of the bottom line is, or the order of the top line is greater than or equal to the order of the bottom line. If that ever happens, you have to divide first. You can see I've divided through here and it's given me 2. It goes in twice with minus 3x plus 1 left over. So I've just written this thing then, goes in 2 whole times, and then this is my remainder over my divider, and my divider really was this thing. So there you can see that's my remainder, and my divider, which has been factorized, was this thing. Okay, I'm just gonna do this bit of it then. We've got to use our partial fractions to do this. So you can see we rewrite it as 1 minus 3x over 2x plus 1 upon x minus 3 is identically equal to a over 2x plus 1 plus b over x plus 3. Multiply across then, 1 minus 3x is identically equal to a upon x plus 3, b upon 2x plus 1. We're putting x equal to 3 minus 3, so that'll make this bracket go to 0. That means x equals minus 3 will be 10 is equal to minus 5b, or b is equal to minus 2. And then again, I'm putting x equal to minus a half to make that bracket equal to 0. So that means 3 minus a half. Oh, have I made a mistake in that? Minus 1 minus 3 times minus 0.5 is, yep, that is 2.5, yep, that's right. And then on the other side then, that's going to be 2 times minus 0.5, and then plus, oh, sorry. Yep, sorry, and then that's 2.5, I'm putting my half, sorry, let's do that bit out here, what I'm doing here, a bit out longer. Right, put that minus a half in the left-hand side, you'll have 1 minus 3 times minus a half. And then the right-hand side, you're going to have a times minus a half plus 3, and then plus that's going to be b times 0. And that's going to be then, I forgot what I've just said there. That's going to be 2.5 is equal to 2.5a. Yep, your a is equal to 1. A is equal to 1. So that's what you've got. That's what you've got. So your answer is 2 plus this thing. Sorted. Okay. Now what you had to do then is use binomial theorem to expand. So when you expanded that, that's what you had. We have said this was what this thing is the same as. Write it out in binomial form then. it's 2 plus, and then I'll write that as 1 plus 2x to the minus half, and then 2 upon 3 plus x to the minus 1. Sorry, that's nonsense. Let's say that again. It was 2 plus, and then 1 plus 2x to the minus 1, and then minus 2 upon 3 plus x to the minus 1. Now this one is absolutely fine. Where we want to get to is this thing in red. You want to get to being in the form 1 plus squiggle, I just say. So it's 1 plus something to the power of n is 1 plus n times squiggle plus n times n plus n minus 1 times squiggle squared over 2 factorial. So this one here is good to go. It's in that form. The other one, unfortunately, this one up here is not. So what I've left a minus 2 outside the bracket, and then I've just pulled a 3 outside, which leaves me 1 plus 3 plus x over 3, and then that whole bracket is the power of minus 1. So the minus 3 gets the power of minus 1, and then the 1 plus x over 3 is the power of minus 1. 3 to the minus 1 is a third, times the minus 2 is minus 2/3, and then this we can now expand, and this we can now expand as well. So when we do this expansion out, we've got our 2, and then expanding out the 1 plus 2x to the minus 1, you'll have 1 plus minus 1 times 2x, minus 1 times minus 2 times 2x squared over 2. And the other one, we had minus 2/3, and it was times 1, plus minus 1 times x over 3, minus 1 times minus 2 times x over 3 squared over 2. That's what 2 factorial is. Tidy that up. 2, each bracket gets tidied up. The first bracket becomes 1 minus 2x plus 4x squared. Second bracket, which was multiplied by minus 2/3, is 1 plus x over 3 plus x squared over 9. And then in yellow are all my numerical terms, 1 plus 2 plus 1 minus 2/3, which is 2 and 2/3. In blue, my x terms, minus 2x plus 2x over 9, which is minus 1 and 7 over 9. And my x squared terms, we had 4x squared minus 2 over 27x squared, which is 3 and 25 over 27x squared. Okay, last question. Okay, right. We've got graph of ln x, y is equal to x minus 2, and x equals 1 is shown. And you've got to, first of all, show that the x coordinate b lies between 3 and 4. So the graphs of ln x and x minus 2 intersect at points a and b is coordinate close to 3. So what b is, if you have a look at what b is, it's where your line y equals x minus 2 and your line y equals ln x intersect. So it says show that the coordinate is close to 3 and 4. You let your f of x equal, that's your ln x minus your line, x minus 3. Tidy it up, you get ln x minus x plus 2. And this question is a location of roots question. So do f of 3, you get 0.0986. Put f of 4, you get minus 0.614. And then you must say this bit to get your marks. Continuous and change of sign, therefore root between 3 and 4. That's it. Next bit. This is Newton-Raphson. It says starting with x equals 0, that's your first approximation is 3. Use the Newton-Raphson method once to find a better approximation. Your formula for the Newton-Raphson method is here. It's given in your formula booklet, thankfully, as I always forget it. It says find your answer correct at 3 decimal places, your next approximation. So you've got your f of x is ln x minus x plus 2. Differentiate that to give you 1 over x minus 1. And then your better approximation is x1 equals x0 minus f of x0 over f dash of x0. So x1 is equal to 3 minus f of 3 over f dash of 3. And you can see what they were, and you can put them in. And you can see you get to 3 decimal places. There's your answer there. I think we're on to our very last question, aren't we? Happy days. My goodness. Right. The shaded region R, as shown in figure 5, is the area enclosed by the two lines in the curve. Using the approximation you have found in part 1, 3.148, find the area of R. Okay, let's go back and see what this is Right, this point here then, we now know is 3.148. So my r is going to be the integral from 1 to 3.148 of my top line, which is ln x, minus my bottom line, which is x minus 2, integrated with respect to x. So that's where we're getting this from. So my r is equal to the integral from 1 to 3.14 of ln x minus 2. Tidy this up before you integrate. Life's tough enough. So tidy it up. You'll have ln x minus x plus 2 dx. Okay, now what we've got here is we've got an integration of ln x. Again, if you go into an exam without knowing how to integrate ln x, this is a standard question they ask. They've built it into a question, a bit sneaky, but it's a nice way of doing it. So you need to know how to do this. Right, you can see in red here, we are going to integrate ln x using integration by parts in a funny way. Integration by parts says if you integrate u dv by dx with respect to x, you get uv minus the integral of v du by dx dx. So that means you rewrite your ln x as 1 times ln x. So your u is ln x, your dv by dx is 1, and then you can differentiate your u to get 1 over x, integrate your dv by dx to give you x, and then that gives you x ln x minus integral of x times 1 over x dx, and that means x ln x minus integral of 1, so that's x ln x minus x plus c. Okay, now go back to this. We now know how we integrate ln x. I'll try and keep that on the screen that you can see it. So you can see this bit here, integrate ln x, that was x ln x minus x, integrate integrate the minus x, you get minus x squared over 2, integrate the plus 2, you get plus 2x, so there we have it, and then you fire in the 3.148 into that horribleness, you get 1.8030716, fire in the 1, you just get 0.5, subtract those, you get 1.0 to 366. Okay, apologies folks, I wasn't doing that out live, but I had already done it and I hadn't recorded. I was gutted, so that's why I just talked through it, but hopefully that makes sense to you. You may have to go through it a wee bit slower than normal. There we go.